Hello students, welcome to VEDA Gate Academy. Myself SIVARAM, completed M.Tech from IIT Bombay, having 10 years of experience in handling gate classes and engineering services. So in this session today, I am going to discuss about one of the very interesting as well as scoring concept called application of Massen's gain formula. As we know, every year in the gate exam, on an average, they are going to give either 1 or 2 marks from either signal flow graphs or block diagrams. And in order to solve the questions related to signal flow graphs or block diagrams, you must have to apply Massen's gain formula. So in this session, I am going to consider some 5 or 6 questions, and with the help of those questions, if you can able to listen the class properly or listen this session properly, then definitely trust me, okay, you can able to attempt any kind of complicated question related to signal flow graph as well as block diagram. So in this session, I am going to concentrate on application of Massen's gain formula. Application of Massen's gain formula. So in this Massen's gain formula, majorly I am going to focus on first one, how to apply this Massen's gain formula to a given signal flow graph. Okay, so the first thing we are going to see how to apply this Massen's gain formula to a given signal flow graph. And second one, even we can apply the same Massen's gain formula to determine the transfer function between any two nodes of a given block diagram, or between any two variables of a given block diagram. So the second one is we will see how to apply Massen's gain formula to a given block diagram. And finally, after finishing of this, we are trying to see some special cases where generally the students are going to make a mistake in gate exam. Okay, so we are going to consider some special cases or special examples we can consider, and in these special cases we will try to play with the application of Massen's gain formula, and in general we will try to understand after finishing of these special cases you came to know when we have to properly apply Massen's gain formula. Okay, so before going to start how to apply this Massen's gain formula to either block diagrams or signal flow graphs or the special examples, first we will try to see what is the statement of Massen's gain formula. If you see the statement of Massen's gain formula, let me move here. So if you see Massen's gain formula, it states that the ratio of output variable to input variable, I am stressing the terms output to input. Okay, so the ratio of output to input is given by summation k is varying from 1 to n, p subscript k into delta subscript k divided by delta. Here, if you quickly see the meaning of the terms in this particular formula, first one, n is nothing but number of forward pass. For suppose if I am giving some x signal flow graph, in that particular signal flow graph, if I am getting number of forward pass as 3, then n becomes equal to 3. If n equal to 3, if I expand this particular formula, then what you are going to get? I am going to get, let me use the pen. So you are going to get P1 delta 1 plus P2 delta 2 plus P3 delta 3 divided by delta. Am I correct or not? Right? So because if I am considering n equal to 3, if I expand this summation, I am going to get this one. So that means based on the number of forward pass for a given signal flow graph or block diagram, I can expand this numerator term in this manner. Now, here, next one, Pk. Pk is nothing but the gain of the corresponding forward path. So if I am getting some forward path, if you multiply the product of branch gains of that forward path, I am going to get the gain of the corresponding forward path. And delta is very important in this particular formula. Delta is nothing but 1 minus sum of individual loop gains plus sum of product of 2 non-touching loop gains, okay, and minus sum of product of 3 non-touching loop gains, and so on. Whereas the last one is delta k. What is the meaning of delta k? The value of delta which is not touching. Here the term not is very important here. So not touching the respective kth forward path. We will try to understand the exact meaning of how to calculate these things once if you start with some particular example. So I hope you understand this formula. So the important thing here is output to input. Okay, I will tell you where we are going to make a mistake during the solving questions. Let me apply this formula. So rather than listening these terms, if I try to apply this particular formula to a given signal flow graph, you can get complete idea. Let me start with one simple example. So this is the given signal flow graph. Okay, and for the signal flow graph, they ask you to determine the ratio of C of S by R of S. So what we need to calculate in this question, guys? We need to determine the ratio of output to C of S by R of S. Let me try to see what is C of S and what is R of S. Generally, in signal flow graph terminology, we are having a term called node. Okay, the purpose of node is in a given signal flow graph is it is used to represent input, output, and some variables which are assigned in the system. Okay, for suppose if I am taking simple RC circuit, in RC circuit I am going to give some voltage that act as a input, and I can measure the voltage across the capacitor or voltage across the resistor. In the control objective, if I mention that measure the voltage across the capacitor, then the voltage across capacitor becomes my output variable. So input is voltage, output is the voltage across the capacitor. Are you following what I am conveying? Right? So that node, okay, that particular variable, so the output, input and some variables which are assigned in that particular circuit are represented in the form of nodes in signal flow graph. Okay, so the input, output and the sum of the variables which are assigned in the network are represented in the form of nodes in what? Signal flow graph, right? So now the nodes are basically classified into three types, as we know: input node, output node and mixed node. The meaning of input node is, if I want to say any node is a input node, it must consist of only outgoing branches. What? It must consist of only outgoing branches. Whereas the node which is having only incoming branches, is called as output node. Whereas the node which is having both outgoing, incoming, okay, so both outgoing and incoming branches is called as mixed node. So I hope you understand this point. Now let us try to see C of S. If you sit here, can I say, is it consist of incoming or outgoing? If you sit on C of S at that particular point, it is having only incoming branch. So I can say C of S is a output node. I can use the term ON to represent output node. Similarly, if you sit at R of S, it is having only outgoing branches. So I can treat it this one as an input node. Now I can comfortably apply Massen's gain formula between C and R. So if I try to apply Massen's gain formula, C of S by R of S. So as we know in the formula, first you need to identify the number of forward paths in the given signal flow graph. Let me consider the signal flow graph. Can you tell me how many forward paths are there in this particular signal flow graph? If you try to see in this particular signal flow graph, total you will get 2 forward paths. By the way, what is the definition of forward path? The definition of forward path is, it is a path from input node to output node such that the remaining nodes, all the nodes you have to touch only once. Again, I am repeating the definition of forward path. It is a path from input node to output node such that all the nodes touch only once, and there should be unidirectional flow of signal is going to be happen from input to output. By using that particular definition, okay, for suppose if I am starting from here, so the simple way of identifying forward path is, you can start from input node and see how many ways you can reach this output node. Okay, such that there should be unidirectional flow of signal and all the nodes you have to touch only once. For suppose if I am starting from R of S here, after reaching this particular node, I can travel in this manner or else I can travel in this way also. First, let us try to move in this fashion. After reaching here, I cannot travel in this way. Why I cannot travel in this manner? Because the signal is coming in the opposite direction. Right? Now what I will do, I will further travel in this way. And after reaching here, I will travel further and reach C of S. So this I can treat it as one forward path. Now can you tell me what is the gain of this forward path, guys? So the gain of this forward path is, I can write as G1. So you need to simply multiply the branch gains of the respective forward path. Branch gains mean G1 into G2 into G3 into G4. So you are going to get this one as the gain of the forward path, P1 into some delta 1. I will tell you how to calculate delta 1 later. So because here, if you observe here, I am trying to write the answer in a single step rather than separately writing or separately showing the forward path. Because as we know, in the GATE exam, time management is very, very important. If you are keep on writing so many number of steps, then there is no point of writing those steps, right? So indirectly we are wasting the time. So let me come back here. So make an habituate of reducing the number of steps while solving any particular question. So here, this is one forward path. Now again, I will try to start from here. And after reaching this particular point, now instead of going through G2, now I will travel through G5. After reaching here, again I will reach C of S in this fashion. So this is also treated as one more forward path. Now can you tell me what is the gain of this forward path? You will have G1, G5 and G4. So plus G1, G5 and G4 into some delta 2 divided by delta. Divided by what, guys? Delta. Here if you observe the formula of delta, 1 minus sum of individual loop gains plus sum of product of 2 non-touching loop gains minus sum of product of 3 non-touching loop gains. That means the entire formula of delta is involving loops. So you need to identify first how many loops are there in this system. How to identify the number of loops in a given system? To determine the number of loops, you can start from any node and see how many ways you can reach the same node. By the way, what is the definition of a loop? Loop is a closed path where starting and terminating node must be same. Again, I am repeating, loop is a closed path where starting and terminating node must be same, such that the remaining nodes you have to touch only once. The remaining nodes you have to touch only once, and there should be again unidirectional flow of signal is to be happen. So if you quickly again see the definition of a loop, loop is a closed path where starting and terminating node must be same, such that the remaining nodes you have to touch only once, and there should be unidirectional flow of signal. If I apply the definition of a loop, let me try to start from here. If I start from here, can I move in this direction? No. Can I move in this direction? No. But I can move through G5. Okay. But first what I will do is, can I move in this way? Yes. And according to the definition of loop, I have to reach the same node. So in order to reach the same node, I can travel through minus h1 and reach the same node where I have started. So this is considered as a loop. Let us consider assign the gain of this loop as L1. Can you tell me what is the gain of this loop L1, guys? So if you observe here, product of branch gain G2 into minus h1, which will give you minus G2 into h1. Now let us try to identify the other loops. So for suppose if I start from this particular node, I can travel in this way, forward way in this fashion. And in order to reach the same point, what I will do, I will travel in this direction, right? So this is considered as a loop L2. So here, if you try to see the gain of the second loop, can you tell me what is the gain of the second loop? G3 into minus H2, which will give you minus G3 into H2. This is my loop L2. Now, again, if I start from the same node here, and I can travel in this fashion, and I can reach the same node where I have started, this is also treated as a loop L3. Can I assign the gain of this loop L3? Can you tell me what is the gain of this loop L3, guys? So the gain of this loop L3 is minus H3. Yes or no? Right? So these are the three loops. Now, will I get any loops apart from these three loops what I have drawn here? Yes, you are going to get. Will I get any more loops? No, no, no. You won't get any more loops, right? Am I correct? So you are going to get only three loops in the given diagram. Now, if you see the delta formula, you will have 1 minus sum of individual loop gains. I will write over here 1 minus sum of individual loop gains. That means you have to add these three loops, L1 plus L2 plus L3. And what is the next term in the delta formula, guys? You will get alternative minus and plus symbols. The second term in this delta formula is sum of product of two non-touching loop gains. That means you need, out of these three loops, you need to identify how many loops are not touching. How many loops are not touching? Can I say this loop L1 and L2 are touching? Yes, they are touching. They are having a common node here. And what about loop L1 and L3? They are not at all sharing any common node. So we can treat it loop L1 and L3 are non-touching loops. So what is the second term? Sum of product of two non-touching loop gains. I can say multiplication of two non-touching loop gains L1 and L3. Do you have any more combinations apart from L1 and L3? If you observe L2 and L3, can I say L2 and L3 are touching or non-touching? They are touching because they are sharing a common node at this point. So they are touching. So the only combination is L1 and L3. So this is my delta formula. 1 minus of L1 plus L2 plus L3 plus L1 into L3. Where L1, L2, L3 are these things. You can substitute over here. Now we are left with one more last term. What is that last term? Delta K. If you clearly observe here, what is the formula for delta K I have given? The value of delta which is not touching the respective forward path. That means if I consider the first forward path, what is the first forward path, guys? G1, G2, G3, G4. Right? So if you observe G1, G2, G3, G4, that means this color. So for this particular forward path, you need to identify how many loops are not touching that forward path. Again, I am repeating, you have to identify out of these three loops, which loops are not touching. For suppose, out of the three loops, if I am getting some one loop, which is not touching this particular forward path, with the help of that loop, again, you have to write delta formula. Okay. So you need to first, what you have to do for a respective forward path, you need to identify how many loops are not touching. Let me try to apply this. For suppose if you are considering this first forward path, for this first forward path, can I say loop L1 is touching? Yes, because it is touching at this point over the entire period here. What about loop L2? Even loop L2 is also touching. What about loop L3? Loop L3 is also touching here. So there are no loops which are not touching the first forward path. So since there are no loops, delta 1 becomes, you are going to get 1 minus 0. 1 minus 0. This is delta 1. You can clearly understand while calculating delta 2. For calculating delta 2, I need to consider this second forward path. What is the second forward path, guys? G1, G5, G4. Now, can you tell me, for this second forward path, is there any loop which are not touching? There are no loops which are not touching, because if you observe here, for forward path 2, this loop is, this particular loop L1 is touching at this position. What about loop L2 is touching at this position? Loop L3 is also touching. So you are going to get 1 minus 0 over it. Are you following? If at all, if any system is having a forward path for this forward path, if any loops are not touching, then with the help of those loops, you have to write the corresponding delta K formula. You can understand over the period. Okay. So have you understand? This is the basic formula. And here, if you observe here, I have written this particular step of C of S by R of S in a single step, rather than separately representing the loops, forward pass and all those stuff. I hope you understand this question, right? So let me move on to the next question so that you can get some more idea. So now this is a basic application of Massen's gain formula to a signal flow graph. Now we will try to understand how to apply Massen's gain formula to a block diagram. Most of the students, engineering graduations students, what they will do is they are trying to apply reduction techniques, block diagram reduction techniques, interchanging of summing point, shifting of branch point after a takeoff point, or shifting of summing point after a takeoff point. Likewise, they are going to play with some reduction techniques, and the major disadvantage is it is a time consuming process. In order to arrive the overall transfer function C of S by R of S, we have to do so many iterations to get the final answer of C of S by R of S. So in order to overcome that one, even still we can apply Massen's gain formula to a block diagram, because in the GATE exam nobody bother about whether you have followed the correct procedure. That means intentionally in the question, okay, if they ask you to determine C of S by R of S using block diagram reduction technique, in the GATE exam you need not to follow the same block diagram reduction technique, because nobody will see whether you have solved with the help of block diagram reduction technique or using Massen's gain formula, because our ultimate aim is to save the time in the GATE exams, right? So now if I can try to apply the Massen's gain formula directly to the block diagram, so what I have to do, I need to write the answer for C of S by R of S. Now let us try to see how to apply C of S by R of S. So first step, what you have to do, you need to identify the number of forward pass. In a given block diagram, if you want to determine C of S by R of S, in order to identify the number of forward pass, you can start from R of S and see how many ways you can reach the corresponding node C of S. If you start from R of S, okay, now I can travel in this way. After reaching this particular point, either I can travel in the upward direction or I can travel in this fashion. First, what I will do is I will move here. After reaching here, can I move in the downward direction? No, because the signal is coming in, the arrow is in the upward direction. So what I will do, I will further travel in this fashion. And after reaching here, I cannot move in this fashion, right? Because what will happen if I move in this fashion? For suppose if I move in this fashion, this particular summing point, how many times it is touching? So it is touching. This is one time and this is second time. So no node is or no path is going to be met more than once. So this is not the correct way. Now again, further I will travel in this fashion. After reaching here, can I move in the upward direction? No. What is our ultimate target? We need to reach C of S. I can comfortably move in this fashion and reach C of S. This is first forward path. Now, what is the gain of this forward path? Simply what you will do is multiply the transfer functions of the blocks as well as the signs of the summing points. Okay. In order to get the forward path gain, multiply the transfer functions of the blocks and signs of the summing points. Here, what is the sign of the summing point while forming the forward path? Plus G1, G2 plus C of S. So you are going to get finally G1 into G2. This is P1 into delta 1. Next, if you see the second forward path, again I will start from here. And instead of going in this fashion, now I will travel in this way and move G3 and finally reach C of S. This is my second forward path. Now, can you tell me what is the gain of this forward path, guys? If you observe here, the gain, here you will have G3 and there is a minus sign is there. You need to be very, very cautious about the signs available at summing point. Otherwise, what will happen? The product of forward path gain will changes its sign, right? So now, can you tell me what is the gain of this forward path? G3 into minus, so you are going to get minus G3 into some delta 2 divided by delta. Delta formula is, you know, that 1 minus sum of individual loop gains. Now, can you tell me how many loops are there? So, to identify the number of loops for a given block diagram, what you have to do is the better procedure or best procedure is you can start from any summing point, and see how many ways you can be able to reach the same summing point. Okay. So, likewise, for all the summing points, you can identify how many ways you can reach, and out of all those things, you have to consider, okay, unique loops. Okay, I will tell you now. Here, if you, for suppose, if I am taking this summing point, for this summing point, can I move in this direction? No. Can I move in the downward direction? No. The forward way I can able to move is in this fashion. And according to the definition of loop, okay, if I am starting from some particular summing point, I have to reach the same summing point. In order to reach the same summing point, I will travel through H1 and finally reach the same summing point in this fashion. So I can consider this is loop L1. What is the gain of this loop L1, guys? The gain of this loop L1 is G1, H1, and you need to be very cautious about the signs available at summing point. So what is the sign? G1, H1 minus symbol. So you are going to get minus G1, H1. Next, Coming to the other loops, for the same summing point, let me try to even evaluate, is there any other summing loops are going to be get. So I cannot move in this way or in this way. The forward way I can move in this fashion. After reaching here, instead of going in the downward direction, further I will travel here. And after reaching the summing point, can I move in the upward direction? No. So I cannot move in the upward direction, but I can travel in this way and reach the same summing point where I have started. So I can consider this also as a loop L2. Now can you tell me what is the gain of this loop, guys? The gain of this loop is G1, G2 plus symbol, and after that you will have minus symbol over here. So what is the gain of the second loop L2? The gain of the second loop L2 is G1, G2 and minus symbol is there. So you are going to get minus G1, G2. Now will I get any loops apart from these two loops which we have shown here? No, because for suppose let me take a different color. Now if I am starting from here, okay, I cannot move in this way or in this way. The forward way I can able to move is in this direction, and I can reach the same point where I have started here. Now if you consider this particular loop what I have shown here, can I say is it same as the loop L2 diagram what I have shown? Yes, you have to consider the unique loops, okay, which are not common to both the summing points. See here, this particular trajectory of the loop whatever I have shown is common to both summing points. Okay, we have to consider only one. So there is no need of showing this particular thing, right? So the two loops which we are getting are minus G1 H1 and minus G2 G1 G2. Will I get any loops apart from these two things? You may have a doubt that. For suppose if I am starting from here, okay, if I am starting from here, okay, I can move in this way. And after reaching here, can I move in this way? No. After reaching here, can I move? Okay, after reaching here, where I have started now, I have started at this point. Now I have to end at that point only. Now my question is, can I able to move in this fashion to reach this point? No, because the signal is coming in the opposite direction. So this is not treated as a loop. Let me undo this. So this is about the brief idea about the number of loops in this particular diagram. Now can you tell me, is there any two non-touching? Only you will have two loops. Can I say these are touching loops or non-touching? They are touching loops. So what is the value of delta 1 minus L1 plus L2? Now the last one is you need to determine delta 1 and delta 2. Now for the first forward path, can you tell me out of these two loops, can I say both the loops are touching? Yes, both the loops are touching. So I can say 1 minus 0. Now for the second forward path, what I have shown. Okay, can you tell me what is the second forward path? This is the second forward path what I have shown. For the second forward path, can I say out of the loops L1 and L2, is there any loops which are not touching? I can say loop L1 is not at all touching the second forward path because my second forward path is starting from here and it is moving in this direction. But the loop L1 is shown here. So is there any common point is there? No, right? My loop L1 is not at all touching the second forward path. So whereas what about the loop L2? I can say loop L2 because if you see this second forward path, this is my second forward path. For the second forward path, loop L2 is touching over this period, right? So I can say L2 is touching loop. But you have to identify the non-touching loops. So you will have only one non-touching loop for the second forward path. And with the help of that loop, you have to write the delta formula. Can you tell me what is the delta formula? 1 minus sum of individual loop gains which are not touching the first forward path. Okay, or sorry, whatever the forward path which we have shown. So for this forward path, I can see loop L1 is not touching. So you are going to get 1 minus L1. I hope you understand now how to calculate delta 1, delta 2 and so on, right? So this is how we need to apply Massen's gain formula to a given block diagram. Now I will give you one more interesting question which was asked in the GATE exam, okay, which was asked in the GATE exam. So this is a previous GATE question which was asked for 2 marks, and nearly 90% of the students, they made a mistake while solving this particular question. What they have done is, okay, so what they have done is, first I will tell you the procedure. So what they ask you to determine is, they ask you to determine what is the ratio of C of S by R of S. And they have given the options in this fashion. They have given option A equal to 0. First option they have given as 0. And the second option what they have given is 1 by S plus 2. Sorry, 1 by S plus 3 they have given. And third option what they have given is 1 by S plus 2. And fourth option what they have given is 2S plus 3 divided by 3S plus 4. These are the 4 options what they have given. Now, we'll try to first apply according to the student way of thinking. Now, for suppose if I don't know how to apply Massen's gain formula to this given block diagram, what generally the students will do is they are going to apply block diagram reduction technique. Now, if you see the block diagram reduction technique, first what we have to do is we need to identify is there any blocks which are connected either in series or cascade, whatever it may be, or in parallel. Now, if you observe here, this 1 by S plus 2 and this 1 by S plus 2 both are connected in parallel. Yes or no? Right? Because the input to both these blocks are same. Output of both the blocks are connected to the same summing point. So I can say both these blocks are connected in parallel. Now, most of the students, what they will do is they will make a mistake while reducing these two blocks which are connected in parallel. Okay, why? Because they think that since these two are connected in parallel, so the output what they will do is they will indicate here. Can you tell me what is the output of these two? Here 1 by s plus 2 minus sign is there. This is 1 by s plus 2 plus sign is there. And both are having same transfer functions, right? So 1 by s plus 2 plus symbol, 1 by s plus 2 minus symbol. So what is the resultant answer? Whenever if two or more blocks are connected in parallel, the overall transfer function after reducing those parallel blocks is equal to either summation, addition or subtraction according to signs available at summing point. Here if you observe here, the signs available at summing point is plus and minus. So if I am adding these two, resultant answer becomes how much you are going to get, guys? 0. So here after getting 0, the student what they will do is they will make a mistake that the 0 may be coming here. And since 0 is the signal which is going to C of S, so C of S is equal to 0. So the answer becomes what they will do is they will keep as 0 as the answer. Now can I say 0 is a correct answer? 0 is not a correct answer, it is wrong. Why 0 is wrong answer? Now let us try to see here. Now here this is 1 by S plus 2, guys. Or else I can consider some block, any block. Let us assume this is block G1. Okay. And I have a summing point, or let me try to draw the same thing here. Okay, so this is plus symbol, and I am going to consider the same block G1 because in where G1 in this case is equal to how much, guys? 1 by S plus 2. This is minus symbol. Now here this is my output, what you are going to get. Am I correct or not? Or else in general, for suppose if I am trying to draw in a normal fashion, for suppose if I am taking this is block G1 and this is my summing point plus minus, and this is also block G1 and this is output. Okay, here the output of reducing these two blocks which are connected in parallel will appear over here. So that means since these two blocks are connected in parallel, if I reduce these two blocks into a single block, that means what I have to do, I need to reduce these two blocks into a single block in this fashion, right? So if I try to reduce these two blocks into a single block, then the resultant block transfer function what you are going to get here is, okay, the resultant transfer function, this is my input, and what you are going to get either addition or subtraction available at the summing point G1 minus G1 you are going to get, this is my output. Can you tell me what is the value of G1 minus G1? You are going to get 0. 0 into input becomes output values, you are going to get 0, right? So the point you need to understand here is the output of the parallel combination of two or more blocks will be appeared at the output of summing point. So here the output here you are going to get 0. That means the point what I want to convey is you won't get 0 over here. After reducing these two blocks which are connected in parallel into a single block, the resultant answer of the output will be appeared over here. Okay, so that means 0 will come over here. Are you following what I am conveying, guys? 0 will be coming here, not over here. If you can able to understand this, then you can easily solve the question, right? Then you can easily solve the question. Now I will try to see how to solve this question. Let me try to erase this. There is no need of this. I hope you have understand what is the mistake you are going to make here. So the mistake what you are going to do is you are going to keep 0 over here, and definitely it will be available in the options. Now let us try to further do the analysis with this method only. So here since 0 is coming here, the same 0 will be coming over here. So the same 0 if coming here, can you tell me what is the signal coming over here? So signal is output of summing point. What is the output of summing point? R of S minus 0, which will give you R of S. Yes or no? The same R of S will be amplified by 1 by S plus 2 times. So you are going to get 1 by S plus 2 into R of S is the signal which is going as output to C of S. Yes or no? So now can you tell me what is the value of C of S, guys? C of S is equal to 1 by S plus 2 into R of S. And what is our interest in this question? We need to determine C of S by R of S. Can you tell me what is C of S by R of S here? Simply 1 by S plus 2. So the answer is 1 by S plus 2. This is, I can say, signal assigning procedure in our common terminology. So what is the answer? 1 by S plus 2 is the answer. Now what I will do is, for the same block diagram without making these many complications, if I apply directly Massen's gain formula, I can able to arrive to the same answer 1 by s plus 2. Let us try to see whether we are going to arrive the same answer of 1 by s plus 2 by applying Massen's gain formula to this block diagram. So let me remove this, right? So even try to remove this. Yeah. So this is the block diagram what they have given, right? So for this block diagram, what I have to do, I need to determine C of S by R of S. For this, what you have to do, you need to identify the number of loops which are available, forward paths which are existed in this particular block diagram. For that, I can start from R of S. After reaching here, can I move in the downward direction? No. I can travel in this way. After reaching here, I can travel in the downward or forward direction. First, I will move in the forward and reach C of S. This is one forward path. Can you tell me what is the gain of this forward path, guys? This is plus 1 by s plus 2. You will have 1 by s plus 2. P1 into some delta 1. Right? Now, will I get any more forward paths for the same block diagram? No. Because again, if you start from here, after reaching here, if I try to travel in this way, after reaching, can I move in the upward direction? No. Because the signal is coming in the opposite direction. So, only one forward path you are going to get. P1 into delta 1 divided by delta. Delta is 1 minus. Now, can you tell me how many loops are there in this given block diagram? How to identify the loops? You need to start from any summing point and see how many ways you can reach the same summing point. For suppose, if I start from here, can I move in the out in this direction? No. Can I move in the downward direction? No. But I can travel in this way. After reaching here, I can move in the downward direction because I cannot travel in this way, and finally reach the same summing point where I have started. So this I can consider as loop L1. Can you tell me what is the gain of this loop, guys? What is the gain? 1 by s plus 2, and there is a minus sign. So you are going to get minus 1 by s plus 2. Will I get the only one loop, or one is there any chance of getting one more loop in this given block diagram? You will get one more loop. If we can able to understand that point, then it is very easy for us to get the exact answer, right? Let us try to see whether we are going to get one more loop or not. I will start from the same summing point, guys. Now, after reaching here, instead of traveling in this way, now what I will do is I will travel in this direction. And after reaching here, I can come back to the same summing point where I have started. So can I say, is it a loop or not? It is a loop because it is perfectly satisfying the definition of loop. Loop is a closed path where starting point and terminating point must be same, and there should be unidirectional flow of signal, right? So now can you tell me what is the gain of this loop? If you clearly observe here, the gain of the loop is 1 by s plus 2. There is a minus sign over here and over here. So minus into minus plus 1 by s plus 2. Now, for this forward path, red color forward path, can I say these two loops are touching or non-touching? So this is loop L2. I can say for the forward path, these two loops are touching. So since both the loops are touching, there are no loops which are not touching. So the delta 1 becomes 1 minus 0. Now this minus 1 by s plus 2 plus 1 by s plus 2 will get cancelled. And what is the resultant answer I am going to get, guys? 1 by s plus 2. So this is very simple, right? Once if you are comfortable with applying Massen's gain formula to a signal flow graph, it is very easy for us even to get the same thing for block diagrams also. So this is how we need to apply Massen's gain formula to a given block diagram. Okay. Now the point what I would like to stress here is these papers, okay, whatever these questions, 65 questions in our GATE exam are prepared by the topmost faculty from IITs, 7 IITs like IIT Bombay, Chennai, Kanpur, Kharagpur, Delhi and Roorkee, right? So generally the faculty what they will do is they won't spend much time on framing these kind of questions, but they will spend lot of time on framing the options. What they will do is they will think where generally the students are going to make a mistake, and they will solve the entire question with that particular procedure, and they will get some answer which they are going to keep as option. Okay. So here the first mistake what they will do is, if they are applying block diagram reduction technique, they may keep the 0 at this position. If they keep the 0 at this position, this is the answer what you are going to get, which is actually wrong. Am I correct? Now the second thing is they are framing even the option B very carefully. I will tell you why. Because most of the students, they are unable to even identify the second loop. If they are unable to identify the second loop, and if I solve the question, okay, the numerator is as it is 1 by s plus 2, denominator 1 more plus 1 by s plus 2, this L2 loop will not be there. If this L2 loop is not there, then what will happen, guys? Let me try to write over here. So what you are going to get, 1 by s plus 2, right, divided by 1 minus of minus 1 by s plus 2. If you are not going to identify the second loop, then what will happen? If I do the simplification, the simple answer what you are going to get is 1 by s plus 3, which is there in option B, but which is actually wrong. So that means what I would like to convey here is, you must have to be very, very cautious while determining the number of forward pass as well as number of loops. If you do any silly mistake while identifying number of forward pass and number of loops, the entire answer becomes wrong. And definitely whatever the wrong answer you will find in the options, because in the exam we never bother about whether we have followed we have identified the exact number of forward pass and loops or not. Once you, after solving the particular problem, and if you are getting some answer which is available in the options, then without any second thought we will simply keep that option. But make sure that you must have to be identify the exact number of forward pass and loops. Okay, so this is what I would like to convey, and this is the way we need to apply Massen's gain formula to either signal flow graphs or block diagrams. And in the next session I will try to discuss about the most important and critical concepts of special cases of Massen's gain formula. And stay tuned with the next session. Thank you.